Hi, this is actually the third video of a short mini-series on D3.js. In the first two videos, we learned what D3 is, and we had a closer look at data in D3.js and how we join that with DOM elements. Now, in this video, we're going to take what we learned there. We're going to build a simple project or a simple demo where we will utilize D3.js to build an interactive chart and use what we learned in the last two videos. So let's get starting building this little demo project or little demo chart, dashboard, whatever you want to call it, with D3.js. For that, below the video, you'll find a link to a GitHub repository with this starting setup, which is a HTML file with a very rough HTML structure in there, some divs, a SVG element, unordered list, some CSS styles which are defined here in this file, and in app.js you find some dummy data which I prepared in advance. Now that's where we are going to pick up on. My goal here is to render a nice little bar chart where we render that data, and next to that bar chart, all those items, so all those controls for USA, India, China, Germany, where we can basically toggle those items so that we can add or remove them dynamically to and from the bar chart. That's the goal here. So therefore, it's of course up to us with what we want to start. I will start with the chart. So I will make sure that we actually have a nice chart before we then later make sure we can add and remove stuff. Now for that chart, I'm going to set up some constants here. For example, a chart width of, let's say, 600, and that will be interpreted as pixels later. And a chart height of, let's say, 400. And these will be our chart dimensions for the chart we're going to render. So next we can render the chart. And for that, I'll first of all define my chart container and get access to my SVG element here in the DOM. So to this element here with D3 select. That will be the container that holds my chart in the end. I will render all the chart elements, so all the bars, for example, in that SVG. Now on that SVG, I therefore want to set some attributes. I want to set the width attribute, so that's basically as if you manually added width here on the SVG, but we're going to do it in code. And I'll set that to my chart width, so to this constant defined up there. Now let's move that into a new line to make it easier to read. And then also add the height here and unsurprisingly set this to chart height. So with that, we define the chart area, and we can refer back to this chart container, which holds a pointer at this selection to then, well, render stuff into it. And that's actually what we're going to do next. To this chart container, I want to append a new element, and that will be a G element. Now, this is a regular HTML element. It is a SVG element, to be precise, and it creates a so-called group in SVG. And we can use this to group together other SVG elements. And I simply want to group all my bars together later, so that's why I create this new group here. And I will store this in my chart constant, because that group will hold the actual chart elements, so to say. So that's just a little helper constant. The more interesting part happens now. On this chart, I now want to select all elements with a bar class. And such elements don't exist yet, but we're going to add them. And that's what I mentioned in the first two videos of this mini-series. Especially in the data join video, I explained this again. Here, we select elements that might not exist yet to then join data with them so that D3.js is able to figure out which elements are missing for the provided data. So that's the next step then. I selected those elements. Now, as a next step, we can call data on those selected elements to join them with some data. And the data I want to join them with is my dummy data here, of course. So this data here. Now, that allows D3.js to find out which data is missing or redundant, and we get access to the missing data by calling enter. So this now basically gives us the information D3.js derived for which elements are missing. And therefore now on enter, we can call append and append new elements. And I want to append rect elements. That's also a regular HTML, or to be precise, SVG element for creating a rectangle. Now, on those rectangles, I also want to add a class. And that should be the bar class, of course, because we're using the bar class here for selecting the elements. So we should also append elements with such a class here. So this will now render or add new rectangles with that class for all the missing data points. Now with that, if I reload here, we see the chart area, but we don't see any bars in there. Now if I select this, we do actually see, though, that rectangles are being rendered in there. They're just not visible, which is, of course, not ideal. Now, they are not visible even though they have a fill color. So the reason why they're not visible, of course, is that they're basically having a size of 0 by 0, so they have no width and no height. Now, we need to change that, and we can change this on the rendered bars here by adding some attributes. For example, a width attribute, but also, of course, a height attribute. Now, the question is which values should be entered here, and I showed this in the very first video of this mini-series already. We can hard-code some values here, but we actually want to derive the width and the height based on the number of data points we have and their concrete data values. And we don't just want to take those values and hard-code the number of data points or anything like that. Instead, we want to let D3.js provide a scale for us. We want to let D3.js translate that number of data points and the values to concrete widths and heights that fit into our available space here. And for that, we can create D3.js scales. Now, we already have the right import for that in the starting setup. So now all we need to do, maybe here after setting up those constants, is we can create a x scale, or maybe just x constant, which holds a function created with the help of D3 scale, and then here for the x-axis I want to create a band scale, which basically means we'll have some equally sized items which are distributed along the x-axis. And for the y-axis, I'll create a linear scale so that we basically are able to, well, reflect those values with appropriate relations to each other along the y-axis. Now on scale band, I'll call range round to define the available range, and range round simply rounds the actual calculated numbers then. And I'll define the range here to go from 0, so all the way on the left on the x-axis, all the way up to chart width, because we, well, do have that maximum width available. And I also want to have some padding, and with the padding function or the padding method here, we can define that we overall want to have 10% of padding, not between each item, but instead in total. 10% of the space basically is reserved for padding. And D3.js with this scale band method and so on will automatically figure out how much space should be between the items. It will count the available items and do all of that for us essentially. Now for a scale linear, I also define a range, not a rounded one, but here I want exact values to be as exact as possible on the y-axis. And here, the range has to start with the highest value because, as you learned in the earlier videos, the coordinate system that D3.js uses behind the scenes starts in the top left corner. So therefore here we start at chart height and go all the way to 0, like this. So these are our available ranges here. And with those ranges defined, let me close that so that we have more space. With those ranges defined, we also need to do one other thing, which we could do here by chaining, but which I'll do in a separate line. We also want to define our domains. So on the X object, which we have here in the end, I will call domain. This allows us to specify how many items should be positioned here, or which data should be scaled. That's in the end what domain does. And here, I'm basically pointing at my dummy data, and I want to transform this array of objects into an array of strings so that we have some unique identifiers that D3.js can use here. And for that, I'll simply extract my region here from every data point. And that basically tells D3.js that for this X scale, it should take this array and it will see that there are 4 items in there, and it will then have all the information it needs to create the different positions along the x-axis for that data. Now for y, I'll do something similar. There I also specify a domain, but here I want to have a domain that goes from 0 to some value that is a bit bigger than our biggest value here. So that this is the full available y-axis that would support a lowest value of 0 and let's say a highest value of 15. Or to be a bit more dynamic and flexible, we can use a built-in helper method on the D3 object, the max method, to which we can pass our data. And then as a second argument, we provide a function that D3.js should execute on every data point to tell D3.js which property in our data is the one it should use for calculating the max value. So here we can then, for example, reach out to the value. And with this, D3.js will have a look at all the values in all our data points and basically use the biggest value here and extract that and use that here therefore as an upper bound. Now, since I want to have some empty space above my tallest bar, I will add +3 here, so that simply there is some extra headroom above my, biggest value, which was derived from my data. So with that, we defined the domains, which will be mapped into the actual available widths and heights. And x and y are now functions which we can call to get the concrete positions along the x and y axis. And with that, we also can get the width and the height. For the width, so for the x-axis, we can call x bandwidth. This method basically gives us an equal width for all bars, and it simply takes the total number of data points, the available width, and calculates the width of every bar, taking into account the padding. That's what the bandwidth method in the end does and gives us. Now for the height, since we start the top left corner, we'll take the chart height and deduct the calculated y position from it. So to y, I then want to pass my concrete value for the different data points, and therefore here for the height, I actually pass in a function, an anonymous function, that gets the data for this data point for which this rectangle was rendered, and we can then feed data.value here to y to calculate the position along the y-axis for this element and deduct this from the chart height because we start in that top left corner. And now we also want to set the x and y positions, of course, so that we don't just have the width and the height, but also where the items should be. And for this, in both cases, we get access to our data point and then call x data.region. For the x-axis, we use the region because that is what we used here for the domain. And for the y-axis, we always referred to the value, so here we call y for data.value. And now with that all out of the way, with this code added, if we now reload here, we see our nice bar chart here. Now this is not too bad, but I think some labels would be nice. And with that I mean labels on the x-axis to see which country belongs to which bar, or which bar belongs to which country, I guess, and also labels above the bars so that we can see which value is being charted here. Now let's start with the labels above the bars. For that, we can reach out to our chart again, and here select all elements with a label class. Again, we have no such elements yet, but that will change. Because with the data method, we're going to join our labels with the dummy data. And now we want to find out which data is missing with enter. And for every missing element, I append some text. Now, text here is simply another HTML or SVG element for rendering text inside of a SVG. So this is not the text which will be output, this adds a text element instead. Now on that text element, we can call the text method to set the actual text that should be displayed. And that text, of course, depends on my data point, and there I want to retrieve the value, like this. Now if we save that and reload, we don't see the labels though. Now the labels are there. You can see them here, very small here at the top, but they're not visible because they sit in the top left corner. I mentioned that the coordinate system starts there, and we have to move them to the right positions therefore. Now again, we do this with attr for setting the x and y attribute and therefore their position in that coordinate system. So the x position in the end depends on our data point, and here I want to call x for data.region because generally I want to have the same coordinate as my bar has. But the problem with that alone, if I do that for x and y, is that for x especially, the data is at the very beginning, and for y it's also a bit too close to the bar. Now to change this, for y it's simple, we just deduct, let's say 20 pixels. We have to deduct it and not add it because we're calculating from the top. So if I deduct 20, you see now there is some space on the y-axis. But we also want to position this in the middle of the bar. And to do that on x, we can simply add something to the calculated position to move it further to the right and get the width of our bar with x bandwidth and divide this by 2. And if we do that, you see now it's further in the middle. Now it's not entirely in the middle because now actually it starts in the middle, and because the text then is laid out to the right, this is not entirely what we want here. But that's something which we can easily change by adding another attribute where we set the text anchor, and that is an attribute we can set for the SVG text element, to middle. In addition, I'll now also add my label class here and set this to true. With that, if we reload, the text is in the middle and it is purple as well. Now that's the label above the bars. Now for the label below the bars, where we say India, China, Germany, and so on. For that, we want to add an axis. And just as with the scaling, there is a separate package. I mentioned that D3.js would be quite modular that helps us with rendering axis. We simply have to add this import. So let's do that. Let's go to the HTML file and add this import here. And once we added this, we can start creating an axis and add this to our chart. Now I'll do that here before I render my bars, though the exact position shouldn't matter. And append a new group, which will hold my axis, where I then will call a function. Call is a default JavaScript method which you can call on function objects. And in the end here, I want to call a function exposed by D3. And now, thanks to this axis import, we can call axis bottom here. And this will create a bottom axis for my x scale. So I pass my x constant, which holds a function itself, to axis bottom. And this function object, the x function object, holds all the information about our x-axis scale. For example, here, thanks to our domain mapping, it holds the regions. And axis bottom extracts that data basically so that it knows what to render at which position for which item. So all the heavy lifting of knowing where to render what is taken care of by this axis bottom function and by the axis package. Now also call attr on that and set the color of this to a hex code to 4F009E. That's of course optional, but should make it look a bit nicer. And if I save that, you'll see something strange. You'll see the axis is there, but it's at the top, even though it's called axis bottom. Now there is an axis top as well. Let's call that and see what the difference is. Now we have no labels, because the difference actually is axis top and bottom does not refer to where it's being rendered in your coordinate system, but where the labels are. With axis top, the labels are above the axis, and therefore they're cut off here. With axis bottom, the labels are below the axis and therefore visible. But of course, we want to move the entire axis down, and that's something we simply have to do manually by adding another attribute here, the transform attribute, which allows us to move that down. Here I'll then pass a string literal with backticks instead of single quotes, and call translate here as a CSS function, so to say, to translate along the X and Y axis. And on the X axis, I don't want to move it. But on the Y axis, I'll set this to chart height. And this will simply move the axis down by the height of the chart. Now, if I do that and reload, you see the axis is gone. And that's also not what we want. Now, it's gone for the same reason why we didn't see the labels on the axis top case. The axis is simply cut off. I moved it down by the entire height of the chart, and that of course means that it's now outside of the chart. Now, that's not what I want. So we could of course deduct 20 from that, for example, but now the axis is in my bars, so that's also not what I want. Instead, what I'll do here, what makes sense, is here, where I define the height and the width and so on, I'll add a new margins constant, which is an object with, let's say, a top margin of 20 and a bottom margin of 10. And here, for calculating the height, I will now take the 400 and deduct my top margin and deduct my bottom margin. And I'm doing this because now when I set up the height of my chart container, I will re-add those margins. So here I add them again. But when I then later refer to the height, I'll have the height without the margins. So there simply will be some space for example, the axis. And now with that, if we push down the axis by just height, you see here it is. Now you also see there is a little tick at the beginning. You might or might not want that. If you don't want it, and I do not want it, you can call another method on axis bottom. You can call tick size outer, written like this, and set this to 0. And with that, the outer ticks, so the beginning tick here, for example, is removed. And with that, we got this finished chart with an x-axis with the labels above the bars. Now for the second part of this demo here. I want to make sure that we have some controls that allow us to dynamically add and remove these bars. And for that, I'll scroll down further in my code file here and actually create a new constant, list items, where I use D3 to select the element with the ID data. And that simply is this div here. I select that, and in there I will actually select the unordered list. And now in there I will select all list items. Again, we don't have those items yet, but you already know in the meantime that we can join some data to change this. Now I will join my dummy data here, of course, and I'm interested in the data that's missing here. With enter, I get that data, and we can then append new list items like this. Now, on my list items, I will then call append again and append a span, where I set the text to data, which I extract from the data point by using this function form, and I'm interested in the region. With that, if I reload and shrink this a bit, here you see these items on the right here. Now I want to have a checkbox which allows me to add or remove the items, and therefore on list items I will append an input on every list item, where I set the attribute type to checkbox, and this will add a regular HTML input element where the type is checkbox. And I'll initially also set it to checked by adding the checked attribute and setting this to true. And with that, we got this nice checkbox next to the items. Let me zoom in a bit more again so that this is a bit easier to see. Now, currently clicking the checkbox doesn't do anything. So therefore, on those rendered checkboxes, I will add an event listener, and D3.js has got us covered here. We can use the on method to register event listeners, for example, to the change event, which will fire whenever that is clicked. Now, the cool thing is here we of course have a function that is then executed if that change event triggers. And here we get access to the data point for which it triggered. So we don't get access to the event object or to the checkbox, but instead really to the data point that was rendered here. And that's really cool because that helps us a lot with working with that data. We don't have to manually extract it somehow. Instead, we immediately get the correct data here. And we can simply console log the data here to have a look at what we get exactly. Save that and go to the console here. reload. And if I click on the checkbox for India, you now see here is our India data point. And for China, I get the China data point, and so on. Now, I want to keep track of my unchecked elements. And for that here, I'll add a new variable, which I'll name unselected IDs, which is an array that initially is empty because initially all items are selected. And then here, whenever a checkbox is clicked, we can check if unselected IDs already has that data point. With index of, for example, we can check for the data ID. Every item has an ID field, so we can check if that ID, which is just a string, is already part of unselected IDs. And if that actually returns -1, if index of returns -1, we know this ID is not part of unselected IDs yet, so it wasn't unselected before. Hence, we want to add it by pushing data.id, so that ID string, to unselected IDs. Else, it was unselected before, and in that case, I want to set unselected IDs equal to unselected IDs, filter, so I want to set it equal to a new array, which is an array I derive by filtering for unequal IDs. So I'm basically going through all IDs that are in unselected ID, and I check, are you not equal to the ID we clicked on? If yes, I want to keep you, because then you were not removed. And otherwise, if you are the ID we clicked on, then you are no longer unselected, so you will not be part of the new unselected IDs array, which is generated here, and which is then stored here. So with that, we're either adding or removing an ID to or from that unselected IDs array here. And now the interesting part comes. Now I want to re-render my chart. I want to update the data in the chart with my new data that should, of course, include or not include data points based on whether their ID is unchecked or not. And to make that happen, we have to refactor our code a bit. To be precise, we have to put some code here into a function. All the code where we render our bars and our labels, that has to go into a function now. I'll name that function render chart, and I'm going to take this code where we create the bars, the labels. So that code here will go into render chart. With that, we can call render chart whenever we checked or unchecked a new item. But we'll still have another problem. It's good that we manage the unselected IDs here, but in the chart we're using the dummy data, and that data never changed. So in order to make sure that we actually reflect our changes, I will go to the beginning of the code file, maybe here below those constants, and add a new variable, selected data. And initially that is equal to dummy data. And it's now the selected data that should be used inside of the render chart function, which will rerun when we change the data. Now, the domain and so on, there we can still use the dummy data because I don't want to change the scaling or the axis. You could do this as well, but I'm not going to do it here. So therefore, I only care about the data inside of render chart. And here I use selected data instead of dummy data, and the same here. Now, of course, we have to change selected data. I want to keep it here, by the way. I really only want to change it in render chart. But now we have to change selected data here before we call render chart. Otherwise, our unselected IDs are still not being reflected there. So selected data is then dummy data, but filtered. So a new array derived from dummy data. And my filter criteria is that I check for every data point in dummy data if unselected IDs holds the ID of that data point. If that is equal to -1 here, then I know the ID of this data point is not in unselected IDs, and therefore I want to keep the data point. If this is anything but -1, I know the ID of this data point is part of unselected IDs, and therefore that data point should be removed, and it therefore is not part of the new selected data array that is derived. And thereafter I call render chart. Now with that it will not work though. If I reload, you see now nothing is being rendered here. And the reason for that simply is that our entire chart rendering logic is now in render chart, but we never call this function. Sure, we call it if we click a checkbox, which is why then the chart appears once we uncheck something and re-add it. But I also want to call it initially when our app starts. So here, before I render my list items, I will call render chart actually. With that, if I reload, the data is there initially. If we uncheck the USA though, you see nothing changes. If I recheck it, also nothing changes. So we're not really doing anything. Well, it makes sense that nothing changes because we don't have any logic to remove bars, for example, and we need that. If we uncheck something and we remove it in our data, which we're doing here, then we also want to be able to remove the DOM node. So for that in render chart, it's nice that we have logic to render new bars, but we also need logic to remove bars. And for that, I'll select all my bars here again and join them again with selected data. But now here, I will call exit to get information about the data that should be removed, and I'll call remove on that data. And the same for the labels. Of course, I also want to remove labels for data that's not there anymore. So on the chart, I'll select all for all the labels, join that with my selected data, call exit, and then remove to remove the labels as well. If we save that and reload and uncheck the US, we see everything is gone. That also doesn't look right. Now maybe our logic here for updating selected data is wrong. So let's console log selected data, and let's see how selected data looks like after we unchecked something. So if I reload and remove the US, you indeed see it's an empty array. So we have some error here. Selected data should be based on dummy data, and we want to filter there. But yeah, this should not be data ID, but d.id, because that's the input argument we're getting here. So that was a tiny mistake on my side. I, of course, want to use the actual data points, the actual elements of dummy data. So with that fix here, if I now reload, you see now only one item is removed, but it's the wrong one. It's always Germany. And this is an error we also kind of had in the second video of this mini-series, if you remember. There we also had the problem that the last item was changed or removed, even though we actually removed the first item. The problem here is simply that D3.js is not able to correctly identify values. It has an array full of objects, and that makes it hard for D3.js to find out which item actually changed. It just sees that the overall length of the array changed, but it doesn't know exactly which item changed. To help D3.js with this identification, we actually want to let it know which key, which unique identification criteria it can use when it binds data. And we do this by passing a second argument to data, which is a function that gets this data point, so that runs on every data point, which should return the value that should be used as a unique identifier. And that therefore should be the ID field here. So now whenever I call data, I will actually pass this second argument, both for entering and for exiting, and this helps D3.js correctly identify our values and the DOM nodes that belong to them. And with that change made, now you see indeed we do remove and re-add the correct value, the correct bar. And that is actually it. That's it for this video. That's the little demo here, which kind of sums up what I mentioned, what I explained in the last two videos of this mini-series. And this hopefully gets you started with D3.js therefore. It can be difficult to wrap its head around D3.js, but it can be quite powerful once you get the hang of it. Now, this series hopefully got you started with getting the hang of it, and I strongly recommend that you dive in the official documentation of D3.js and the different packages like D3.access to learn all about it, and then simply play around with it. That really is the best thing you can do if you really want to master it. Play around with D3.js, find out what you can do with it, run into problems, solve them. That is how you're going to grow.